So in this question here, we've got a parametric curve with the equations x equals 3 sine 4t and y equals cosine squared 5t. And we want to find dy dx, the rate of change for this parametric curve at any point t. So our building blocks are dy dx, but they are in terms of t. So what we're looking for is dy dt divided by dx dt. Derivative of y with respect to t, derivative of x with respect to t. So that's what we're kind of looking for. Now let's get our building blocks. So dy dt, let's take care of this one. So dy dt. So we've got cosine squared 5t. So what we can do is bring a 2 to the front, and then we've got cosine 5t. So 2 cosine 5t. And then by the chain rule, we need to multiply this by the derivative of cosine 5t. Now the derivative of this is negative sine. So remember it's multiplied, so we just put this in a bracket. So times minus sine 5t. And then by the chain rule, we also need to multiply by 5. So let's times this by 5 as well. So let's just simplify this out. So we've got 2 times 5 is 10, and with a minus we've got minus 10, and then we've got cosine 5t sine 5t. So cosine 5t sine 5t. Okay, right, that takes care of that, but we could actually combine these into one trig function. So remember, the identity we have is sine of a plus b, that equals sine a cosine b plus sine b cosine a. So if we're looking at this one, we can just let the a equal 5t, and we can let the b also equal 5t. So that'd be our sine and cosine for 5t's, which we've got in both terms. So then the sine of a plus b would give us the sine of 10t, and then we've got sine a cosine b, so that's cosine 5t sine t. Let's write that one in there. So let's just go with it as it is. Sine 5t cosine 5t plus sine 5t cosine 5t. As these are multiplied each term, I can write them in the correct format. So that's those. Now that there, if I just look at this bit, that bit there is just one of these, but I've got 2. So this here is only half of what I've got here. So therefore, if I divide this by 2, I've then got this one here. So cosine 5t sine 5t, that equals 1/2 of sine 10t. So then what I can do is now just simplify this off, multiply this by 1/2. So I've got minus 5 sine 10t. So that takes care of that one. So that was quite a lot to do for that one. But now this one here, dx dt, let's just do this one here. Let's keep that separate. So dx dt, a little bit more straightforward. It's just sine. The derivative of sine is cosine. So I've got 3 cosine 4t, and by the chain rule multiplied by 4. So times that by 4. So that gives me 12 cosine 4t. So that takes care of that. So now I can set up my result for my parametric differentiation. dy is minus 5 sine 10t. So that's that. And the denominator is just 12 cosine 4t. And I'm going to leave that as it is. I'm sure there's more trig identities we could do, but I'm going to leave that one as it is and declare that one as my answer. Okay.